Hello and welcome to another tutorial. We are going to continue on discussion of the how to create objects using the new operator and what the syntax is and what happens behind the scenes. So we've already seen how to use the new operator. So a typical Java program creates a lot of objects, and then through these object interactions, a program can carry out various tasks, such as implementing a GUI, running animation, sending and receiving information over a network. Once an object has completed the work for which it was created, its resources are recycled for use by other objects. Now, we have to be careful here about the word resource here. Usually, there are two types of resources in a application. When you run it, and when you run an application, doesn't matter if it's a Java application or anything, it becomes a process on the operating system, and operating system has to handle that process. And the way operating system handles the process is, first of all, at the start of the process or at the start of the application, the operating system has the task of allocating memory to your process, right, to your Java application, for example. And we saw that in the previous lectures, how JVM requests for memory, what is the concept of max memory, total memory, or free memory, etc. And then so memory is definitely the most precious resource that your application needs. The other one is other type of resources. For example, files are on the permanent hard disk, for example, right? That's the permanent storage. That's some sort of resource, and your application always goes through the operating system to get access to those types of resources like files, network handles, sockets, etc., right? And sometimes your application, which is running on a process, can communicate with other processes that the operating system is running. It's called the inter-process communication. Usually the concept of sockets, process sockets, are something that you use to interact with other running processes. But usually, I mean, at least for the beginner Java applications, when we say resource, it's either the memory, Java heap, etc., or the file handlers, I/O resources, right? In general, you can say that it's I/O resources. And an I/O resource could be file I/O, network I/O, etc. And so let's say memory. If an object has completed its tasks and it's no longer necessary, we know that and we saw that you usually have a pointer or a reference type to that object, and that pointer could be a local variable or a field. If the pointer is or the reference is a local variable, as soon as it goes out of the scope of the method, for example, that local variable is no longer available on the stack frame because the stack frame of that method is destroyed. Therefore, and if no other reference is pointing to that created object, then the data that object holds on a Java heap is no longer available. So it becomes garbage, and that's the concept of garbage, memory garbage. Here's a small program called create object demo that creates 3 objects, 1 point object, 2 rectangle objects. You will need all 3 source files to compile this program. So I mean, we said that your Java application, the entry point is always a method which is called main, and it's a static method. It doesn't depend on the state of any object. And then we are creating some local variables of type references, which are just behind the scenes. These are pointers. And we saw also the concept of compressed references, why JVM launches with 32-bit pointer types instead of 64-bit. Even if you launch your Java application on a 64-bit platform, JVM still tries to start with 32-bit pointer types, and to save memory, right? If your application doesn't create many objects, many local variables of type pointers, then if there is a 32-bit address space is enough, then JVM decides to start with 32-bit addressing. What this means is that JVM tries to first look at what is the maximum memory that is specified. If you explicitly specify, I need more than 4 GB of memory for the maximum, then the JVM says, okay, there's probably a need for that, and therefore we have to go beyond the 32-bit addressing. But for now, you can assume that each one of these references is a pointer, and the object itself, also the state of the object, occupies memory on the Java heap. The pointer is a variable, it's a local variable on the stack frame of the method, and it occupies some memory on the stack frame. And depending whether JVM is working in a 32-bit addressing mode or a 64-bit, then these references occupy either 32-bit or 64-bit. And we know that the stack frame of the JVM of the method is 32-bit. So 64-bit is occupies 2 slots on the stack frame. So we're creating objects, and then when we know that when you concatenate a string with an object or something, what happens if it's a pointer type or a reference type? What happens here is that every object inherits from the superclass object type, right? And so every object can be converted to a string, or it can be concatenated with a string. And what happens behind the scenes is that the compiler calls the toString method on this, right? So let's have a quick look at this one too. So class, let's say object references. So, or let's call this creating objects. Let's have a main method so that we can launch application through this class. So every object can be converted to a string, because the superclass object class has a method called toString. It has a default basically implementation, so it's not a abstract method, right? It's a public method. It's non-abstract, which means it already has a body, or we call it a default implementation. So it gets the name of the class at and then integer 2 hex string hash code, and this hash code by default returns the memory address, which is a 32-bit, which is very interesting. What this happens is that hash code, unfortunately, is defined as int, not long, which means it always returns a 32-bit integer. And obviously, the toString, the default implementation, it converts to hex, right? The question is, what if the JVM launches in a 64-bit addressing mode, right? Then, because then the memory addresses have to be 64-bit. You can try to play with this, and what happens usually, even if the JVM launches in a 64-bit addressing mode, if you explicitly request more than 4 GB of max memory, this hash code and this default implementation still returns a 32-bit integer and a 32-bit hex. And usually that's because you probably even though the JVM is 64-bit, you never consume that 32-bit address space. It's still 4 GB, and usually you don't have 4 GB of local pointers or local references. But let's create a class here. Let's say example class, and then we're not going to extend anything, right? So if I say just a string s equals some empty string and then a space plus, and then let's create an example of this class. So whenever you have a class, note that I cannot declare this as public. That's not going to work, because we saw that in a source code you can only have one public class. You don't need to have any public class in a source file, and you can have multiple class definitions in a source file. That's fine. Every one of these class definitions gets compiled to a separate class file. This is a very important concept which we discussed. I'm going to show it to you one more time. So if we go to oops, so I have this example class, and as you can see, it's compiled to a separate class file than this one, creating objects. So every class definition gets compiled to a separate class file, even if multiple class definitions are in a source file, right? So there's a distinction between source and class file, and we know that the best practice is to try to keep only one class definition in each source file, and the other restriction is that only one of the class definitions can be public in a source file, and the name of that public class has to match the name of the source file. And again, we had a very detailed discussion about these restrictions and why these are in place. I'm just trying to quickly refresh your memory. So let's see what happens for the new operator. So creating objects means we are calling the new operator on a constructor of the class. Right now we didn't explicitly define any constructors, so the compiler Java C adds the default no arg constructor, which is always public by default, right? So if I look at the class file, this example class, if I open it with the class file viewer, yeah, let's put it side by side. If we zoom in, you see that the class doesn't have a modifier public. So this type package, and remember the fully qualified name of a type is, it's basically the name of a type, it's fully qualified name. So example class, that's the constructor, and as you can see there is no public modifier. So actually JVM didn't put a public modifier for the constructor itself, because there is no point. We know that if there is a restriction on accessing the type, because this is a package level access, it doesn't matter if we can explicitly call the constructor and define it as public, that's fine. Now in the class, in the bytecode, we do have public, but it really doesn't make any difference because the type itself is not public, it's package level. So if the type is package level, obviously the constructor is going to be either package level or private or protected. Public constructor doesn't make a difference, because for somebody to call this public constructor, they have to be able to first access the type, and the only way, and then first, so the access modifiers for the type have precedence on the access modifiers of the constructor, right? So we just there's no point in declaring this constructor public, for example. All right, let's go back. So we use the new operator. So we say that basically you define a variable of the type example class. Let's say C1 is new. We call the new operator, and then the name of the type, which is basically one of the constructors, and then Eclipse's autocomplete tells me that this class only has one constructor that doesn't take any parameters. And then once we do this and run the application, JVM creates an object, initializes the state based on what code goes into the constructor, this particular constructor, and then it gives us a reference type or a pointer type that is stored on the stack frame of the method. So the object itself, when we say object, it means the state of the object, right? The data that the object holds, it is stored on the Java heap, and we get a pointer to it, right? Or a reference to it, which is stored on the stack frame. As soon as we go out of the stack frame of this main method, for example, this variable C1 is destroyed. And in this particular application, we don't have access to any other, basically then we lose access to the actual state of this object on the Java heap, the data. And therefore we say that this object is out of the scope and has become garbage. Whenever an object is garbage, it's basically qualified for garbage collection. And we saw that finalize method in the Java, which is a protected method. So subclasses can override the finalize method, and it's not recommended. The best practice is to forget about finalizers. That's not a good practice for the most recent versions of Java, right? But when the objects go out of the scope and JVM at some point realizes that it's running out of the memory, because JVM can never go beyond the maximum amount of memory that is specified at launch time of the application, then the garbage collector can kick in and clean up these memory garbages, these classes that are out of the scope and have become garbage. So first of all, let's see what happens in the bytecode when we invoke the new operator. So I'm going to open the class file for this particular main method. Let's zoom in. Let's bring this here. So in the main method new, it's just a synth. So the bytecode is in fact new. And as I mentioned before, JVM, so JVM only recognizes types, which is fully qualified name, And we saw that how JVM resolves these fully qualified names using the class path variable, right? So JVM starts from the class path location and looks at your fully qualified name. Packages translate into directories from the class path. So JVM tries to find the class files for a given type which has a fully qualified name based on the package hierarchy. So as you can see, it says new, but it doesn't say new example class, right? It says new whatever the name of the type is, and the name of the type is the fully qualified name. So the bytecode new has a bytecode, and then the fully qualified name of the type. It's not the name of the class, it's the fully qualified name of the type. And again, type means fully qualified name, right? I mean, type means interface, class, enum, anything. And JVM only recognizes fully qualified names. Types, the name of the class only is a convenient way to write it in the source file. But in the bytecode, there is always the fully qualified name. So we call the new operator on the fully qualified name of the type. And JVM starts from the class path location, all the directories that the class path pointing to them, and then based on the package names, it tries to find a folder directory hierarchy and tries to find a class file that is inside this OOP folder, right? And there is a dupe, which means duplicate. So what does this mean? Like, we are duplicating something. So what is this? And after dupe is invoke a special something. So what is this? We know that obviously after the new is new just tells JVM allocate memory in the Java heap, and JVM looks at what type you are allocating memory for. So so JVM knows that how much memory to allocate for this particular type, right? dev.java.oop.example. So this new bytecode only allocates the memory. But then invoke a special, we are invoking some. When you say invoke, it means we are calling something, some method, right? It's not a field. We're not accessing a field. We're calling some method. It's a special method, and the prominent example of a special method is the constructor. We saw that all the rules that apply to methods also apply to constructors because they're just methods, right? But they are treated as a special method. Invoke a special, so calling the constructor has a special bytecode which is called invoke a special, which means call a special method which is constructor. So we are calling constructor, a particular constructor. Obviously, if the constructor takes some parameter, then JVM knows which constructor to call. All right, so we are invoking, and we said that the use of new operator is to allocate the memory and initialize the class using the particular constructor and the parameters that we pass to the class. Okay, and then a store C1, we've seen this before. For this is for storing some variable at some location of the stack, and that variable has a type. We saw that I store means store an integer type, a means store a reference type. So this a store underscore 1 means store a reference type, which is the prefix a, right, at location 1 of the stack frame of method. So we are basically storing which is called C1. Remember, this name is not part of the bytecode, but Eclipse shows it just because Eclipse also knows what the name of the variable was in the source code, right? But the actual bytecode is a score underscore 1. And then we just return. So this new this line of code apparently translates into quite a number of bytecode lines. One is the new operator to allocate the memory. We have to duplicate and then invoke a special, and then a store 1. So 4 bytecodes. So new, we just allocate the memory, and then we have to duplicate it. So what happens here is that for this static method, we know that at a slot 0 in the basically a slot 0 of the stack, or a stack location 0, we know that this args is located, right? And that's what we're seeing here is a local variable args is at index 0 and type is a string array. And then because this is a static method, we know that this pointer is not passed, right? But then we allocate this one new, and then we get a pointer to it. So we're going to duplicate that pointer, and then we're going to duplicate it basically so that we have a access to it, because and this duplication I believe doesn't happen, or basically what this happens at somewhere else, not on the stack frame. There's some extra memory probably, and then this duplication is basically is going to copy the pointer to the newly created object on the Java heap, and then we're going to call the constructor and then initialize the state, and after that we store it at index 1, because obviously index 0 was this local parameter or local argument args. So the next store is basically a store 1, right? And again, this is a 32-bit pointer at the moment, because the stack is every a slot, every location of the stack is 32-bit, and we know that this object reference, a string array, is just object reference, which is 32-bit, right? So we are storing at 0 and 1, and then we return. So 4 lines of bytecode to translate the new. First, we allocate the object. We know what the size is going to be, and then we allocate the memory, and that's hidden from us. In the bytecode, we just have new. So JVM behind the scenes knows how much memory in the Java heap to allocate, and then it's going to do duplication, and then invoke a special, call the constructor and initialize the state of the object, and then store this pointer into the local variable, and then we return. Okay, so that's what happens when we just say new operator. And then next, we saw that every class can be converted to a string implicitly if we cascade it or try to concatenate it with a string. So a string val plus c1. This is going to translate c1 to a string, and then that string is going to be concatenated with this string again. So let's look at this one too. All right, so as you can see, we store c1, and then we invoke virtual Java lang string builder append. And we've seen that in the most recent versions of Java, concatenation apparently by default always happens using a string builder. So always happens using a string builder. So when Java compiler saw that we're concatenating it, it's creating a string builder object behind the scenes, appending this string to this, and then calling the toString. So it passes the it passes the original raw string, this one, to the constructor, or basically it creates a string builder with a string, and then calls the append Java lang object, and then a string builder to a string, and then a store s2. So at some point this c1 is, we are loading c1, and when you pass it to the append method of the string builder that takes an object, inside that append method is going to call the toString on this object, right? So extracts the string representation of c1 and then append it to whatever. And eventually, because a string builder is a reference type, we want to assign it to a string, so it's going to automatically call the toString method on the string builder and return a string, which can be stored in the s1, which was a string representation, right? So every object can be converted to a string. That's the general contract the object class provides. It has a toString method. So if we move on, so we have a point class. It has an explicit constructor, rectangle. It has some public fields, methods, and it has some overloaded constructors. We saw that similar to methods, you can overload constructors. And the following 3 sections use the above example to describe the life cycle of an object within a program. From them, you will learn how to write code that creates and uses objects in your own program. You will also learn how the system cleans up after an object when its life has ended, which means it has become garbage, which means the data that was associated to the state of this object on the Java heap is no longer referenced by anybody else. Nobody's using it, so this data, this amount of memory is garbage. Creating objects. As you know, a class provides the blueprint for the objects. You create an object from a class. Each of the following statements taken from the create object demo program creates an object and assigns it to a variable. So new, we call some constructor, we pass some arguments. We saw that Java is always passed by value. So JVM doesn't care about the name of the variables. You can never change a variable inside a method or a constructor call, because what JVM sees is the copy of value of these constructors, of these variables, right? Any variable that you pass, either it's a literal or some variable, the value of that variable is going to be copied, and JVM only sees the actual literals that represent the values, and then they are copied into the parameters in the stack frame of the constructor or a method, and then after some new operator is done, it returns a valid reference. The first line creates an object of the point class, and the second and third lines each create an object of rectangle class. Each of these statements has 3 parts. discussed in detail below. Declaration, the code said in bold are all variable declarations that associate a variable name with an object type. And again, every variable has to have a type. When you call the new operator and call a constructor of a type, all constructors have the same name as the type, and it returns a type. And again, one thing to note that is we know that this class is inside this package, so we don't need to use fully qualified name, but we do in fact can, right? We can use the fully qualified name. That's fine. That's basically what you are supposed to do, unless the class is in the same package, right? That's a default assumption. Otherwise, you have to always use the fully qualified name, and we saw that it's painful, so the import statements help a lot. Obviously, if the type is in the same package, you don't need to explicitly use the import statement. What about the new? So the question is, can we use a new operator with the fully qualified name, or is it always the name of the constructor? So let's see what happens if we write this, say C2, but instead of saying new name the constructor, we use the fully qualified name. And this in fact works, right? So this is still yes, this in fact works. Let's put C2 here, and then we're going to also print a string. So if I run this, this is works, and a string value. So C2, we call the toString on it, and it returns the name of the type, which is the fully qualified name, and at this hex representation of the hash code, which is by default the memory location, right? It's a 32-bit integer. Now, so yes, we can in fact use the fully qualified name of the type when we are calling the new operator, and we're doing the calling one of the constructors, right? So again, the name of the constructor has to match the name of the type, obviously. And then you can use the fully qualified name whether on the constructor as well as the type itself. Now let's say right now we didn't need to use the fully qualified name on either side. So obviously, because this example class is in the same package for us. What about something that is let's say in another package? Do we have a class somewhere? Bicycle, for example, it's in another package. So I can say bicycle. I'm not going to import it because Eclipse can auto import it, and then we can directly use it without the fully qualified name. C3 new bicycle. All right. And we're going to call the default construct. Right now, it's not going to work. So let's see. The package name is dev.java classes.bicycle. All right. And Eclipse's autocomplete helps a lot here. But however, on the left-hand side, now Java compiler knows what the type is because we explicitly have the fully qualified name. But on the right-hand side, it doesn't know what this is, right? Bicycle cannot be resolved to a type because it's actually not the constructor that it's not the name of the constructor, it's name of the type that the new operator understands. Again, when we in the bytecode, it says new and the name of the type, fully qualified name. So first JVM knows, and we know that assignment operator means how you have to evaluate the right hand side first. So before even looking at the left hand side, when we say new bicycle, JVM doesn't know what this bicycle is, right? So we have to explicit the fully qualified name even when we are using the new operator and calling the constructor. Now this works because now we're saying that new this type, and JVM says, okay, you are trying to create an object of this type. I'll go and then allocate memory because now JVM can find it. And then it looks at the parameters or arguments that you pass in these round brackets, and then based on that, JVM knows which constructor of this type, of this fully qualified name of this type to call, right? So it's not true that you have to say new the name of the construct. That's not correct. The correct approach is to always have the type, because when you say new, you have to tell JVM which type, and type means fully qualified name, right? So new plus the type. and then the round brackets and the parameters that you pass, like say arg1, arg2, just guide the JVM to which constructor of this type to call, right? And again, this is something that you typically don't see. People don't talk about it because obviously IDEs are very helpful in terms of just importing the type, quickly importing the type, and automatically adding the import statement. So import bicycle as the type, and then this line is going to work. The previous line still works because again, if you use fully qualified name, Java compiler and JVM, none of them need to look at the import statements, right? Because it's already fully qualified name, so they already can find it, so there is no need to try to look at the import statements. So both of these work. This line, that's what people typically teach, saying that, okay, the name of the type and then new operator, and then you pass arguments, and then based on those arguments and the types, JVM knows which constructor to call. But in reality, what happens here is that new operates on the type, name of the type, which is the fully qualified name. So we are not calling the constructor per se. We are telling the JVM first to allocate memory for this type. And then after that, JVM automatically looks at the parameters and therefore realizes which constructor of that type to call. Now in C++, you can actually just write the name of the type without any round brackets, and the compiler realizes that you want to call the default constructor. So this works. This works in C++, but doesn't work in Java. In Java, you have to specify empty round brackets, because in Java, this statement, new bicycle, just means go ahead and allocate a memory for this type. And obviously JVM can find this type because we have an import statement for it. So JVM goes and allocate, but then it doesn't know which constructor to call, right? So you have to be explicit about which constructor you want to call. So two steps: allocate memory for this type, and then call the constructor based on the arguments that I specify here. So I hope you enjoyed this lecture. In the next lecture, we're going to finish up this discussion. So please stay tuned, and I'll see you in the next one.